Okay, kids, we're ready for some sweet, sweet math. I know what you're saying. You're saying, the generator equation you had up here in the board, that's the math you're talking about. No, 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 we're talking about transformers. Remember, we're talking about transformers. So the generator equation is used for generators. Well, let's talk about transformer math. Transformer math is all proportions. Okay, so it's about how many loops to how many loops. So 2 loops might give you 2 volts. So 4 loops should give you Fruit Loops. Stop it, Billy. Come on, that was actually kind of funny, Billy. 4 loops, yeah, so it's a direct relationship there. So let's write that equation down. It's just a proportion. So Vs over Vp. What do you think the S stands for? Okay, V is for voltage. S is for secondary and primary. Remember, we were talking about the secondary coil and the primary coil. The primary coil is where electricity is coming in, inducing in the secondary coil a voltage, and that goes out. So secondary and primary. All right, now, it's directly related. Ooh, this is supposed to be an N. That'll be directly related to the number of loops. Yeah, and so these are directly related to each other. You know that if you have more of this, you're going to have more of that. So there's our setup for the transformer equation, relating voltage in a transformer and the number of loops, or the number of loops dictating how many volts you'll get out of that. Okay, we'll do a math problem with that just real quick. There's another equation that's important, comes in handy dandy notebook sometimes, and it relates the number of coils with current generated. So this is the number of coils with voltage, then there's the number of coils with current. Now with current, okay, so here I had Vs on top, so I'll put Is on top. That's the current in the secondary coil, and the current in the primary coil. We can also relate this to 2 loops. But with this time, with the loops this time, okay, we don't go S and S. We don't go S and S. No, it flips. It's S and P, and then N and S. So with the current, the P's and the S flip for the coils. All right. Now, actually, you might be relatively intelligent. You are a relatively intelligent person who's watching this. Otherwise, you wouldn't be watching this. Only smart people watch these videos. You're smart. See how smart you are? Yeah. You might say to yourself, hey, if V is related to N and I is related to N, then wouldn't V be related to I? Heck yeah. Whew, that was really good. Very good, Billy. Nice observation. Let's set up an equation relating these two. All right, so let's see. I'll go with, I'll stick with this, Vs and Vp, and we'll relate this to Is, currents. Okay, so before we related V to N and I to N, now relating V to I. Okay, the way this works is since the S and the P are opposite, and up here the S, it was the same as the S, so I'm going to have to put an S with a P here, and being consistent with this, and an I with an S here. So when it comes to voltage and the current, we have the S's and the P's as opposites. Okay, all right, so those are 3 equations. Sometimes one comes in more handy than the other, but the one that's usually used, not always, but usually use this bad Larry right here. So we can very quickly do a calculation with that. Now, you know, some of the problems that we'll be working on, you'll have to use these, but let's check this one out real quick. It's just proportions. This is easy math stuff. This is not difficult. This is proportions. We're talking like, you know, when you guys were 2 and 3 years old, you were working these things, right? Work it, work it, work it, work it. I'm working it. Now, let's say that I have a primary coil with 28 loops. Okay, primary coil, 28 loops. You can see that, right? Yeah, okay. And I have, and this is producing a voltage, let's say 60 volts. And I need, let's say 240 volts. Need 240 volts. So I'm going to make a transformer. So in my secondary coil should have how many loops? How many loops should I have in that secondary coil? Okay, well, just set the proportion. The secondary voltage is what I need. And so what we're going to have here, well, first of all, what kind of a transformer is this? Okay, we're going from a voltage incoming of 60 and outgoing of 240. That's a step-up transformer. So we're increasing that. So our secondary coil and our secondary voltage and our primary voltage, okay, let's set those up. So primary, 60, voltage primary, 60, needed, coming out of the secondary coil, so we're stepping it up, so that'd be 240. And we produce this 60 volts by 28 loops of wire. So the number, okay, this is the voltage of the primary. So the number in the primary is down here on the bottom, 28. And so I'll put an X up there for how many coils I need in the secondary. And you cross multiply, divide, you'll get your answer. So this is going to come out to be 4. And so 4 multiplied by 28, that's 112. Okay, so we'll need 112 loops. 112 loopies El Grande in order to get that, the voltage that I need. Okay, so I mean the transformer equation is pretty simple, pretty easy. Most of those are pretty straightforward. So there you have it. There's the math with it, the equations, and I hope you enjoyed this little tour through transformers. And we hope to see you again soon. Bye, kids.